Welcome back to the Dart language tour. We just finished talking about the main function, and now we want to talk about functions as first-class objects. So starting off with just the definition of what it means to be first class. If you take a flight in an airplane and you have the nice seats up front, where you have a sort of privileged status, maybe you have more rights than the people in the economy seating section, you're flying first class. And maybe you get like a full meal, you get more leg room. There's all these nice things you get with being first class. In countries that have tiered systems or histories of inequality, you then have first class citizens, second class citizens, and so forth and so on. And typically first class citizens enjoy more rights, access to things, more privileges. So functions as first class objects, I don't really know what that means, like transferring that analogy from society or flying first class to a programming language. I don't know what that really means. So let's look at a Wikipedia entry. Let me zoom in real quick. Okay, there is one sentence here, two sentences actually, I think, that are important. So, a language that supports passing functions as arguments to other functions, returning them as values from other functions, and assigning them to variables or storing them in data structures. That's what it means to be first class. That's what we call a first class function. It's just a very privileged function because it can do all these things. It has a lot of abilities. I'd like to see maybe an example of other languages where you don't have first class abilities, and how you work around that to perform the same type of logic in your program to achieve a certain task. It goes on to say some programming language theorists require support for anonymous functions. Those are also unnamed functions. And then in parentheses, they also call them function literals. Okay? Which is important because in some of the avoid function literals, you can see it in the tab here at the top. That's what Dart says to avoid, is function literals in a foreach, for example. But just know that there's a lot of you need to know this terminology: anonymous functions, function literals, unnamed functions. Closures is another thing. We're about to get into a lot of this. Okay. So you can pass a function as a parameter to another function. Basically what they were just saying in that Wikipedia page. That's what makes it first class. So just know that when you hear first class, think, oh, I can pass it as a parameter or an argument to another function. That's all that means. Okay, let's take a look at this example. Okay. I'm just going to clear that out. Now, what I want to show here is that a couple things. In the main function, you can define another function. Okay. I typically will try to list things outside of the main function, but because this is the entry point, maybe we shouldn't have anything outside of the main function. I mean, apart from like import statements, right? So let's break this down. What we're going to do here, we have a function called print element. It takes an element parameter and then it prints it. Okay, that's the name of the function. It's not anonymous. It is a named function. It looks like we have this list of integers here, and for each one of those we want to print the element. And you'll notice here that it's just the name of the function. It's not trying to call the function or do it like that, where it invokes it with the parentheses on the end. It's just a reference to it. Okay. But before we get here to this point, let's do it the hard way. Okay. If this didn't exist and we just wanted to print each one of these, so inside of foreach, what does it take? It takes in, let's say, so coming off of the list, it's going to take each one of these. Okay, so each one of these is an integer or a number. Let's just call it a number. You could also call it an element in the list if you wanted to be generic. And so this is our local variable that represents each iteration. And then we go into this block inside the curly braces. Next thing is we want to print the element. And that's it. Okay. If we run this, we get a little info over here, a little warning, but it successfully does what we want it to do. All right, so I've already opened this avoid using for each with a function literal. Now remember, a function literal, according to this first class function thing, is that it's a synonym for an anonymous function. So here, in between the parentheses for the for each method, we have our little block variable and then the logic. If we wanted to give that function a name like they do up here, that's what we would do. But for now, it's a function literal or an anonymous function. Here is that linter advice. So it says avoid using that. So for example, people for each person, like we had list for each element. Don't do that. Instead, say for, like use an old school for loop. Okay. Or, like they show here, pass in a function name. Now, this is okay to read, but from the effective Dart pages, they actually have a better, more expanded explanation. So there's the linter rule. They're saying the same thing. Avoid iterable for each with a function literal or an anonymous function inside your for each call. It says for each functions are widely used in JavaScript because the built-in for loop doesn't do what you usually want. I would go on to say that Ruby, you can do for loops in Ruby and while loops and do loops and all the old school way of doing things. But we typically use the enumerable like .each or .map in Ruby. And this for each is kind of similar in my mind. That's how I think about it. But then it goes on to say in Dart, if you want to iterate over a sequence, the idiomatic way, which is the standard convention within a language, is to use a loop. Okay, so they go on to say this is what they had in the previous linter. And then they show it's bad to use for each. Okay, and this is that, there's that function literal or anonymous function. They go on to say, and this is what it doesn't say in the linter, note that this line specifically says function literal. If you want to invoke some already existing or named function on each element, for each is fine. And that's where they showed that here. Okay, and then it does go on to say a little bit further that, oh, they show it here as well. Okay, people for each print. So they kind of expand out that linting rule and explain it, which is nice. Also note that it's always okay to use map for each. Somehow maps aren't iterable, so this guideline doesn't apply. But if it's a list or maybe a set, it's different. Okay. So those are those two things I wanted to show for now. Let's go back. Okay. And we could have a bunch of different things we're doing here. We could print more stuff. We can do a lot of things. And eventually we want to extract all this logic. Let's pretend it's a bunch of logic. We'll just leave this one line. Okay, we're going to cut that and paste it. Okay, Now let's give this bit of logic a name. Let's call it print element. Okay, you might be able to see where I'm going with this. Let's say we want to restrict it to integers. All right, and let's give it a return type of void because we're printing in here. All right, now we have the exact same thing that we had here. Okay, so that's how we expand and eventually get to this point. So instead of passing that function literal into the list for each, we can just pass the named function print element, and let's see if it still runs. And it does, so that's good. Okay. I wanted to show one thing as well. Yeah. What is the runtime type of this function? Why can't I do that? Type can't be assigned to the parameter type void. I don't know what that means. Argument type not assignable. Okay. Num. Okay. So I think this is going to return a string, this runtime type. So briefly, let's just get rid of the void. And can we say run now? Nope. Okay, so it's still, I don't think it likes this. Let's be dynamic about that. It's still going to print something, so can we have void now? Error compiling to JavaScript. Function int. Oh my god, mouse. Seriously. Okay. So we're printing something. This is kind of ridiculous. Okay, why would you think that's the same thing? Let's try something else. Another function. Okay, it's just a blank function that shouldn't do anything. I'm not sure what was going on there. Okay, what is it not like about another function? Void function int can be assigned to the parameter type. What is wrong with that? That is really, really strange. I swear I did this earlier. Okay, maybe for each one, it didn't like the calling that. I think that might be what it was. Is I think you can only just pass in the name. You can't call the methods on it, I don't think. Let's see, like toString. What does that do? Okay, yeah, it doesn't like that either. I think this integer it's trying to come off of this list. If, for example, I had these strings instead, now instead of saying void function int, it might say void function string, and also still complain. See, there it does. The argument type string can't be assigned to the parameter. Okay, so it's trying to do stuff in there like that. So that's okay to pass that in there like that. In fact, I'm going to come back and do 1, 2, 3 like so. I want to just say print. I think this is what I was trying to do. Runtime type. I don't want to do a list for each and print the runtime type. I just want to look at this once. Okay, so look, it takes an integer and it returns void. Okay. So I'm going to just hang on to that real quick and leave that there because I think I'm going to show us something in a second. Okay. You can also assign a function to a variable, such as the following. It says this example uses an anonymous function. More about those in the next section. Just remember this thing right here that I'm highlighting, the message block variable, and then it's string interpolating it in an expression to uppercase. That is the thing that could be named, but it is not. It is an anonymous function. Okay, and that is being assigned to this thing called Loudify. And it's a little tricky. Remember, we can't use asserts here, so we're just gonna say print. So it should print true is what we're expecting. Let's see, use a function declaration to bind a function to a name. So that's interesting. But I'm expecting it to print true. Okay, and the reason is, so Loudify is just a reference to this anonymous function somehow. We're passing in hello, it's uppercasing it, and here's our hard-coded expectation of what it should be. That's why it prints true. Let's check out this function declaration to bind a function to a name. This is kind of cool. Okay, prefer function declarations over variables. So even though that we're saying you can also assign a function to a variable, you should prefer function declarations. Okay, do use a function declaration to bind a function to a name, as Dart allows local function declarations. It's a good practice to use them in place of function literals. So again, use them in place of function literals, where this thing is the function literal. You might remember, like if you do I think it was like a map literal. So if I just have an empty map, I can say empty map equals that. Okay, so that's a map literal right there. I could say not literal map, and I could do something like that. Okay, that's an instance of a map. They kind of do the same thing. One is the literal, one is using the object notation, or whatever that's called. Similarly, you can look at like the signature of how this is written and infer that this is a function literal, rather than doing something like perhaps, and I don't know if you can actually do this to create a new function, but what if, for example, let's call this function Loudify. What if instead of doing a function literal, you could do something like this, a function, and maybe that would take like, okay, here's what I'm calling my argument, and then here's going to be my my stuff like this. I don't know if you can do this, but what I'm saying is that in the event that you could initialize or new up a function like so, this would not be function literal syntax, similar to map not being a map literal like this, whereas something like the curly braces or this anonymous function is like a function literal. Okay, let's just comment these things out real quick since we're not using them. Okay, so instead of doing that, they're saying define your function. Okay, so prefer function declarations over variables. And in fact, when you look at this, if you look at a named function, regardless of what it returns, like this is var, but it looks like it returns a string, yeah? So you could also return a string. You could wrap this and say print, okay? So when you call it, it does something, and instead of a string now, it's void. So now it looks a little more like print element, doesn't it? Whereas this is more like Loudify or print message, where it just does it this interesting way. Both have a name, and in a sense, like this print element, it is kind of a storage bucket that stores this logic. It knows it needs this type of argument passed to it. It knows what to do. You can pass it around like a variable in here, okay? That's a reference to this logic. But instead of having an equal sign, it's just written in a different way. So I almost view these things the same way, except for the fact that apparently you can't do, well, yeah, this thing is written a different way. And let's go back to the original. Okay, except for the fact that on line 11, when I print the runtime type, it goes int and returns void. If I print Loudify, okay, dot runtime type, and in fact, I think something interesting is going to happen. Okay, so all it's doing is saying what it takes, an integer versus dynamic, returns void versus returning a string. Let's just print the reference to the function itself. Yeah, this is what I wanted to show. Line 11 says closure main print element. Okay, so it has a reference, like a really good reference in the name of this thing itself. Whereas down here in Loudify, because we defined it with this sort of variable assignment notation, it now just says closure main closure. Okay. It doesn't say closure main Loudify. For example, if we made this instead, like so, can we do that? Does that? I think that might work. Yeah, so now it's main Loudify. Okay, so that's all we had to do to convert that variable assignment function to a proper function declaration. And in fact, you can go a little bit further. That way it looks more exact. If you really wanted to, you could instead do it the old school way. Okay, and you would just say return now. All right, so now we have the real deal, what you might be used to when you look at a function. So anyways, Dart prefers the function declaration. It looks like whenever you print the reference itself, when you're passing that around, you get some extra information. So instead of just being a generic closure, now it has the name as part of that closure. Okay, so these references to functions, you might refer to them as closures or hear them called closures. And there is an entire Wikipedia page on closures. We will actually get down to lexical closures in a couple videos. But for now, I think that's all I wanted to show. We went over all the diagnostic messages. We looked at first class and closure. We did both of these examples. We showed the types. Yeah, use a function declaration, name your functions. You can pass it as a reference like that to certain methods that expect those. We didn't look at how to define that ourselves. Maybe we'll do that at a later time. And yeah, an anonymous function is also a function literal. Okay, and we'll go more into anonymous functions in the next section. So we will see you there.